Okay, so what we are going to do today is first, like, we'll understand what is blockchain. We will also see how Bitcoin is, because that is how everyone got to know the use cases of blockchain, and everything started from there. So that's why it is very important to understand that as well. And the third point is we'll understand what types are there, how many different blockchains can we have, and what all that stuff. We'll also see that as well. So these three will be the main points, and you can stop me and ask questions any in between at any time, because I would prefer that you have whenever we complete few points, I would prefer that you have understood that completely before we go to the next point. Okay, so let's start. So what is blockchain? So blockchain is basically just a way of storing data. It's like it's just a database where but it has some properties, some different properties. The what are those? The first thing is the database is immutable. Means once we add some data, we cannot edit it. We can only add new data to that. It is append only. Append only means we can only add, keep on adding new data. We cannot add, modify the data that has been already added. If I can hide this.
Okay. And so, I mean, if there's an error, right? I mean, what happens? What happens to any form of historical?
Yes, that is like one a quick small problem, but it has huge benefits to make it unmodifiable. So that's why like if a smart contract has, we have some mechanisms, like we have to identify where that error occurred, and we have to rewrite from all the data from that point onwards, and make sure that everyone else also starts using from there. But we cannot go back in time and like go back to some data and modify that data. We cannot do that. It can only be new data can be added. We cannot modify the data. Okay.
So basically, whatever information's in the blockchain thus far. And when you say blockchain, like, I mean, is it sort of like code that you're looking at online? Is it a repository in GitHub? Is it like what am I really looking at when you say like
okay? So can you see this these two diagrams right now?
Yeah.
These two are like two separate blockchains. So this is how this is a block, and we add multiple blocks together, one after the other. And once a block is added to this chain, we cannot change it. Before adding it, we just add new transactions. Like this guy sent Manjit 30 some 30 maybe Ether, maybe Bitcoins, and we just add a list of such transactions, and we add this block to a chain. And once it is added to chain, we cannot modify it. After that, we cannot modify it.
So in what format is that information in?
It is it is in form of list of transactions.
Okay, so I don't know much about this at all. So maybe if you can draw some analogies, like a Microsoft Excel file, or like a Google, maybe a Google Doc is better, so that everybody can see a Google Doc, right? It's not stored in the cloud somewhere, right? It's stored on a GCP server somewhere. Google ensures the credibility of that document, but the permissions are in a certain way. You can't go back and edit the data that's on the Google document. You can only create new data. Is that kind of similar? Or?
Kind of similar, but few things. Every participant has a copy of that doc stored there with them. It is not with Google Doc. What happens is the doc actual data is stored on a Google server at one point, at somewhere at one place. Okay, but in the difference in blockchain is that this data, this entire blockchain, all this data is stored at every node. Whoever is the participant, he has the entire copy of this block, and he has to keep on adding whatever the network is adding.
Right.
Okay.
So just kind of simplistically, for security purposes and audit purposes, it's much better if multiple people have a copy of the original document.
Right. That is where if multiple people and like anyone can have a copy of that, we don't need to trust any central authority. We don't need to make sure that they might change it somewhere, or they might restrict access to some people. They might do anything with that. But if it is public and anyone can have access to all that data, that means we are sure that we don't need to trust anybody. We can just
Yeah.
maybe I can just use my laptop and download the copy of blockchain, and I can be a participant of blockchain node, a Bitcoin node, let's say, or Ethereum node. I can do that on my computer. I don't need anyone's permission.
Okay, so even that, let's make a small note. You can just even show me what that actually means, being part of the Ethereum node or Bitcoin, or block Bitcoin node. But from an efficiency standpoint, isn't it much more efficient to have a centralized? Right? I mean,
No.
imagine like you have one company like Netflix who's streaming. So yes, it's bad because they can make a decision as to what gets streamed or not.
Mhm.
But they're making the huge one-time investment into
Right.
building out the servers, building out the infrastructure. They've raised a ton of money. Isn't that more efficient versus just having 100 small Netflixes just versus having one Netflix?
Right. That is the like blockchain is a as we said here, blockchain is a way of storing data, and very inefficient way of storing data. What we are trading for is we are trading for security and decentralization with efficiency. So we are okay because on further sessions we will understand we don't keep all the data on blockchain itself. We use some other databases as well, and we only keep the data which must be immutable, which must be like the most important data. Let's say for balances and transactions, only those data we store on blockchain, and other stuff we keep on some other networks. For example, if we see NFTs, the image is never stored on the blockchain. Image is always stored somewhere else. Just the hash, the identifier of that image is stored on the blockchain with the owner name. We don't store the
Okay.
exact image or the or not just image, any file. Let's say a video is an NFT. We create a video NFT. That video is stored somewhere else on a decentralized database, and the identifier of that video is stored as an NFT on blockchain. So we make sure that because like everyone is going to have a copy of that, so we don't want to store a lot of data on blockchain. We make sure that the data we store is critical, only critical data we are storing.
Gotcha. So basically, there's a prioritization schema of some sort where only priority one critical information is stored on the blockchain,
Mm-hmm.
and then other aspects are stored. Is it called off-chain or sidechains or
Off-chain, yeah, we can we call it off-chain. Sidechain is actually also a blockchain, but the data we store, I mean, not important data we store on our off-chain data.
Okay. And so, I mean, the blockchain itself, is it, if you pull it up, does it just look like, I mean, is it just code? Is it just thousands and thousands of lines of code? Or
No. A blockchain is a collection of data, collection of transactions. This is actually a blockchain. If you see, this is actually an example how data is stored on a Bitcoin network, and this is how the data is stored on the Ethereum network.
So what's the difference? I mean,
Yes,
they
if you
look
see
the
the
same,
difference in on Bitcoin, the transactions are stored. This is a transaction, not the balance. This is a transaction, not the balance. But on Ethereum network, we are storing the balance. Alice has 200 ETH, John has 85 ETH. Then after some transactions, when we create a new block with executing those transactions, after that, Alice has 180 ETH, John has 49 ETH, and he has 50 ETH. So they did some transactions. We executed those transactions and created a new block. The data, now the stored data on the blockchain is this. And
Okay,
on
so
Bitcoin, we
Bitcoin
only store the
stores,
transactions.
okay, so Bitcoin stores transactions, ETH stores values.
Yes, that the balances, for example, there's not Ethereum actually stores because it is a programmable blockchain. It stores some other stuff as well, but this is how basically it stores. It does not store the transaction itself. It stores the execution, the data after the execution of transaction, whatever the state is there.
Okay.
Okay.
So it's basically like, so Ethereum is a new form of ledger, right?
Right.
Like an accounting ledger.
Okay. And if you pull out a blockchain, you'll only see this stuff. If I can give you an example.
So even in that, Ashish, why is this revolutionary? Or like, I mean, I guess the security aspect is understandable because now you have thousands of people millions of people maybe across the world working on the same platform in one way, right? So I can understand the Bitcoin side maybe to a certain extent, where it's the first time in history where there's a sort of a universally accepted something, right? A set of protocols, I guess, for information storage.
Right.
But and I guess that's maybe where the value is derived. But like, so why is ETH? Because I mean, there's been so many settlement agents, so many transfer agents. There's anybody who does basically kind of account reconciliation in some way. Like so why is ETH so special?
Okay, so actually Ethereum enables, because Ethereum is a programmable blockchain. That is where the difference comes in. So on Bitcoin, for example, we can only send a transaction of this type. We have to specify one address, and we have to specify other address, from address, to address, and amount. We can only specify these three things, and only one function gets run. It transfers the balance from this to this. That's the only thing Bitcoin can do. Bitcoin network can do. On Ethereum, because it is a programmable, we can write complex functions, we can write smart contracts, because it is programmable, we can write like smart contracts that execute a logic, and use that logic to build change data. We
Okay,
can
so
use
in a
some
way,
custom
like
functions to change.
Bitcoin is sort of like sending mail over the post office. Gotham sends to Ashish a letter.
Right.
You receive the letter. It's confirmed and it's done.
Hmm.
Ethereum then kind of puts that letter onto the internet, and I can now start putting formatting, Excel. I can add files, formulas. I can basically customize that
Right.
letter,
Right.
whatever I want it to look like.
You can automate sending mails to some people. You can automate that process. For example, it can have something like, once if this condition is met, just send mail to these many people automatically. I don't need to manually
Right.
do that stuff. So it can do such stuff as well.
So the big thing with Ethereum is that it's programmable blockchain.
Right.
It's
That's the
customizable blockchain.
Yes, and Ethereum is the first programmable blockchain, and it has the highest number of participants, highest number of nodes. That's why it is, and like most users, that's why it is most trusted as well.
So when you say node, is node meaning the number of people who are not number of people, but the sort of like the machines verifying
Yes,
things, or what's the
almost,
definition of
almost.
node?
So I'll explain what a node is. So I explained that this is a blockchain. It contains a block. Block contains a list of transactions, and we keep on adding blocks. This is a blockchain.
Yeah.
So everyone can keep a copy of this, but everyone does not. Like, I do not have currently a copy. You don't have copy, right? So what a node does? Node is someone who has a copy of this blockchain and who participates in a process of adding new blocks. Whoever does that is a node.
Okay, so that a node is the same thing as a miner.
Yes.
Okay.
Okay.
So a node and a miner are the same
Yes.
kind of thing, concept, where it's
Yes, almost
they're
they are same thing. If there might be some nodes who are not mining, actually, they are just keeping a data for their own purposes. If they want to use some data quickly, they might do. It is not compulsory for every node to mine it, but they can be just a node as well. But for almost all, every node mines, because why not? And every node is a miner basically.
okay.
Hmm.
And Bitcoin, is it written in a specific language? Is Ethereum written, like I think you mentioned Hyperledger? Are those programming languages, or how is it constructed?
No. So there are two parts. So for Ethereum, the network itself is written in Go language.
Oh,
Okay, and like there are some parts of other languages as well. We don't need to do anything with that. So if you want to set up your own node, then you have to use some Ethereum client. So because if you want to communicate with other nodes, because obviously everyone should have a same copy of this blockchain, right? So you want to communicate with all the other nodes, to fetch what was the latest block. Is my block correct? Okay, I have added new block. Please, you also add it. So we have to communicate these data to other nodes as well. If I am a node, so for that I have to use something called Ethereum client. For Bitcoin, same thing. Bitcoin client. Okay, and this Ethereum client, that is written in Go and all that stuff. But if you want to write because Ethereum is a programming language, Programmable language. If you want to write smart contracts, if you write to want to program on top of Ethereum, we have to use, there are two languages actually, Solidity and Viper. Okay.
Solidity and Viper.
Yes.
Okay.
This is actually 99.9% all smart contracts are written in like Solidity only for Ethereum, and there are many other chains that are just copy of Ethereum. For example, if we take Polygon network, for example, Binance Smart Chain. So there is a term called EVM. Okay, so we, whatever the code that we write, how it achieves this programmability is, on Ethereum, the Ethereum client, everyone has one something called Ethereum virtual machine. What is that? It is an environment for Solidity code to execute. That's it. Okay, it is environment, means if we have some smart contract that can be executed, that the code has to be executed somewhere, and that is executed on EVM. So whenever you see something called Ethereum compatible, EVM compatible blockchain, that means that that blockchain can that blockchain is a programmable blockchain, and we can write smart contracts in Solidity, and the same smart contract that I have written on Ethereum can be deployed on that blockchain as well if it is EVM compatible.
Are they interchangeable? Like in the sense that can I copy and paste one from the other? Or are they sort of two totally different languages?
No, they are. I think they are totally different languages. The code is not, but I haven't. Frankly, I have never seen any smart contract that is there, publicly used, that has been written in Viper. They are all in Solidity.
Solidity, okay. And who created Solidity? Who's
The same,
founder of that?
the Vitalik Buterin, the founder of Ethereum.
So Vitalik created Solidity.
Yes, yes.
As the underlying framework to create programmable blockchain.
Right, correct.
So Solidity basically is the code. Is it code, or is it actually, or is it more the guardrails?
No. Solidity is actually like a language which we use to code the programmable like parts of that our applications. If you want to build something on top of Ethereum network, we use Solidity to build that for code.
Okay. And so now what I've been hearing is that people can just create these very simple APIs in to Ethereum. So do you need to know Solidity to be able to create Ethereum contracts, or no?
If you want to create a Ethereum smart contract, you obviously need to know Solidity. But if you want to use some there are so many things that are standardized and can be copied or forked. For example, if I want to create a token, if I want to create an NFT, the smart contract will be similar to what other NFT smart contracts are there, right? So I can just use their smart contract and deploy it on my own. So I'll have my own instance, and I can use that as my NFT collection. Okay, I can just copy the code.
You can go into GitHub. I mean, this information is free, readily available anywhere.
Right. If I don't want to anything special that hasn't been already done, then we can just use anyone's code.
And so now, when everybody talks about these ETH competitors, like Matic, Solana, AVAX, so what part of the ecosystem here are they targeting that's better, faster, cheaper? So it's like, why are there competitors to this? And why are there so many, I guess?
Yeah, okay. So we learned that we are creating a new block, right? What we are doing is, and let's say I want to send you some transaction. I want to send you some funds, and I say to you that, oh, I have sent a transaction. How will you confirm? You will confirm when you check a blockchain and you see a block where your balance has been increased and my balance has been decreased. Once you see that, you are sure that okay, the transaction has been successful now, right? Until that, you will not be able to confirm the transaction, correct? Right. So for Ethereum, the new block is added every 15 seconds. Okay. For Bitcoin, the block is added every 10 minutes. Okay. So if I send a transaction to you, I have to wait at least until 15 seconds to make sure that to confirm you, to tell you that, oh, I have sent the transaction. That is the minimum. What can happen is, let's say there is a blockchain. There is a blockchain, and I sent one transaction. So I have to wait 15 seconds. I check the new block, and there is no my transaction is not there. It's still in queue. It has to be added in next block. So I have to wait 15 more seconds. I have to check it here. If I see my transaction, then I can tell you, and you can also confirm on your own that, oh, Ashish has sent you the transaction. Now that is confirmed. So that wait is too long. So they like, for example, Solana. This is what we call. There is a term called transaction throughput. So what does this do? It makes that how many transactions you can confirm per second. Okay, that is how we measure how fast the blockchain is. So this term actually used to compare between efficiency of fiat currencies and our currency. For example, Ethereum has 7 transactions per second limit. So because we are adding every block 15 a block every 15 seconds, and we can only add like few transactions per block, Ethereum can only confirm 7 transactions per second. That is the rate. For Solana, if you see, for Bitcoin, it is even less. For Bitcoin, it might be 3 or 4 transactions. So Bitcoin, it is three
Yeah,
or
yeah.
four. It is even less. For Ethereum, it is 7. For Solana, so mostly this is what they are targeting. For Solana, it is 20,000 transactions per second.
Right.
Okay, so this is the Solana. If you see on Solana website, the first thing that they will tell you is we are fast. Our transaction throughput. This is what the term use. Transaction throughput. That means how many transactions they can process, confirm per second.
But so is Solana also though a programmable blockchain or no?
Yes, Solana is programmable blockchain, but it is not EVM compatible. We cannot use write smart contracts in Solidity and deploy it there. We have to use some other language.
Okay.
The Solana is built in. Actually, Solana uses same language to build the blockchain as well as write the smart contracts. Okay, the
So
language
that's
is Rust.
it's called Rust.
Yes.
So Rust is a direct competitor to Hyperledger.
No, no, no. Hyperledger is actually I think okay. So I will go into Hyperledger. Hyperledger actually is just a project, big project.
Oh, sorry, not Hyperledger. Just go scroll back up. Was it called Validity?
Solidity.
Solidity. Okay, so Solidity and Rust are direct competitors.
Right. Actually, Rust is a Solidity language is created just for building smart contracts on Ethereum. It was created when we are building Ethereum, but Rust is a general purpose language. It is used in it is it is just a normal language like for example Java, C, C++. Rust is like used there as well. It is not specifically created for blockchain. The language was already there even before we had blockchains.
Okay. So it's just another object-oriented language of some sort. It's not.
It
Yeah.
is a normal language. It is Rust is actually a direct competitor to C++.
Okay. So the main competitors to Ethereum are basically saying that it's not necessarily a better programmable language. It's just much faster.
Yes.
Security is the same, right? So
Yes.
security is the exact same. Customization and sort of functionality is probably the same, but just we can verify your throughput in a way that's 50,000 whatever 500 times faster than Ethereum.
Right.
So if you ever want to get to scale, like OpenSea or Rari or Visa, at some point they can't wait 7 seconds to verify a transaction. They have to be able to do 10,000, 100,000 per second.
Right.
It's a global business.
Currently, actually, Visa currently does actually more than 1,000 transactions per second. Currently, there are more than 1,000 Visa transactions happening per second in the world. So that's why for Ethereum, because it is very slow, we have something called side chains.
Uh-huh.
Side chains, and for example, Polygon is a side chain.
So
It is
Matic
also
is a side chain to ETH.
yes. What does a side chain mean? Is what does a side chain do? It combines transactions into and sends them as a single transaction. So what it can do? It can actually combine
Kind of like a compressor. Like a compressor.
right.
It takes It aggregates an aggregator. Sorry.
Uh, yes, exactly. Like what does let's say this is my main blockchain, okay, and I have a side chain. So this is a polygon. So instead of sending transactions to Ethereum, what I will do, I will send transactions to people will send transactions to Polygon. Polygon will create a block and use this as a transaction and send this as a one transaction to this.
Okay.
So we can so the Polygon will also work as a blockchain itself, which we can use Polygon is actually also EVM compatible, so we can use the same smart contract there also, and this will compress these blocks into a transaction, and it will send those transactions to Ethereum.
Okay.
Okay, and
And
also,
does AVAX,
huh?
AVAX, the company AVAX,
Mm-hmm.
AVAX, is that similar to Solana or is that more similar to Matic?
AVX also, I think, is a sidechain itself. Uh, it might be so. There are two different things. For example, it could be also be a separate chain itself. For example, if we take Cardano or Binance Smart Chain, okay, these two are not connected to Ethereum. They are just separate sidechain. They are also they use the same code. They have just changed some stuff, uh, and they are also EVM compatible, but they are separate blockchains. They don't share the data. But Polygon is connected to Ethereum. It is a side chain.
Okay. So why did these guys create separate chains in Cardano and BSC that won't be interoperable with Ethereum?
Okay. Okay. So how it works is why does Ethereum take 15 seconds to create a new block? It can do faster as well, right? Why does Bitcoin take 10 minutes to add a new block? It adds a new block every 10 seconds. It can do faster as well. So there is for security purposes, like very simple thing, we have to make sure that who gets to add a new block is randomly selected, is randomized. We want to make sure that same if let's say this there is a my blockchain, and the authority of creating a new block can be sent to anyone randomly. That is the main problem that every blockchain has to solve, and if they solve that problem differently, then they can make sure that the process of adding the new block is faster. Okay,
Mhm.
so this concept is called consensus algorithm.
And so the consensus algorithm is the compression,
No.
the speed at which it's
No, consensus algorithm is something which decides which of the participants gets to, which of the miner
oh,
gets
okay.
to add a new block.
It's the randomizer. Sorry,
Yes.
it's the algorithm that randomizes who gets to add a block.
Right. So there are few examples. Proof of work. That is what Bitcoin uses and Ethereum currently uses. Ethereum is actually shifting from proof of work to the next proof of stake.
Proof of stake. Proof of stake. Yeah. And what's the difference between work and stake?
Okay, so for proof of work, how does it do? So what in proof of work, what every miner has to do, they have to guess a random number. Okay,
Uh,
that random number they have to start guessing from zero. They have to solve one problem. If zero is the solution, that's it, they have found the solution, and they will get to add a new block. They have to then, if zero is not, they have to try one, then they have to try two, then three, and they have to go until they find the correct value which solves the problem.
yeah.
Okay, and whoever solves this first will get to add a new block. So that is
And
how.
they get rewarded for adding that block, right?
Right.
That's the mining, that's
Yes.
the nodes. So basically, whoever is a miner, the way I can think about it is they've made an investment into the miner with the hope of being able to add using the consensus algorithm, being able to add another block to the chain.
Right. Yes.
Okay.
So what is that reward? I'll explain that as well. So in case of Bitcoin, what the miner gets to do, he gets to add a last transaction. The last transaction row is actually empty, and he gets to send a new transaction to himself. So he says a new transaction from no one, this not actually like this, but I'm just explaining it to myself. And he gets to this amount is actually not decided by him, but that is decided by by the network itself. That was actually decided when we started the blockchain itself, but he gets to add a separate transaction like this. When whoever gets this value first just adds this block, and then this block gets added, so he automatically is rewarded with these many tokens.
And so that is there some like is there some cryptography, or is there some mathematical formula like what makes the ability of that miner being able to confirm and solve that math problem?
Yes, okay. So this is actually something called hashing algorithm. So we have to figure out a perfect hash. So what hashing algorithm is there? I will tell you. A hashing function uh, takes an input data. It can be any data. It can be an image. It can be a number. It can be a string. It can be like any data, and it outputs a fixed output string of fixed length. So let's say of fixed number of 250 digits. So 0 1 1 0 0 like 2 7 something, a random number, an integer, a hex number. Okay, so whatever the data is, it just creates a random. It is completely random. So I cannot let's say I want to create a number that has four zeros and some numbers. I want to create a number. I have to just keep on trying. Without that, I cannot figure out, like from this data, I cannot figure out what will be the input.
Right.
Okay. If I put some input, it will give me some random. It is totally random. So what the miner problem has to do, he has to use this all the list of transactions, whatever the transactions he had done, he has to use that transactions and a random number. So what that input is tell? Input is list of transactions plus a random number. Okay, and he has to create a hash for this input such that the previous 15 digits are zero. Anything. So he has to keep on trying. He has to start from zero, keep on trying until 15 digits are zero. And whoever gets this first, he will say, okay, I have for these many transactions, this is the nonce. I have solved the problem. Now we can add this block. Okay.
That's a lot of work.
Yeah, that's a lot of work. That's why proof of work, it is called proof of work. He has to do work.
And now proof of stake?
And proof of stake is something called what the miner has to do. Once he gets these transactions, he doesn't need to do any work. He has to stake some amount. Okay. So he goes to the network and says, okay, I'm staking, let's say 25 ethers to make this is a stake to make sure that these transactions are validated and they are correct. Okay, so all the miners get to put their own stake. So someone goes and says, I'm staking 25 ETH to make sure that these many transactions I have validated them and they are correct. Someone goes and says, I will stake 100 ETH, and these many transactions I have validated and they are correct. Someone else goes and puts another stake. Okay, and the algorithm randomly selects from these values, and whoever has staked most has the highest probability, is not guaranteed, but has the highest probability that his block will be selected.
Gotcha.
Okay.
Okay.
So this is the algorithm called proof of stake. So we eliminate a lot of computation here. We don't want to keep on guessing until, because this number gets a lot bigger. I should actually show
if we seen the transaction IDs, they're like 26, 27, 28 digits.
Yes. And all of this data is actually there. If we go to, let's say, any Bitcoin block explorer, you will see what transactions are there, what was the nonce that they found to add this block into the Bitcoin blockchain. You can all see that all this data is public. You can see Ethereum also currently uses proof of work only. It is in process to shift to proof of stake.
Right. I've heard that ETH is that big migration is moving from POW to POS.
Yes, ETH 2.0.
They said it's taking them a lot of time and a lot of effort, but it'll help the throughput, right? The TPS
Right,
pretty significantly.
right. Because
Yeah.
in Bitcoin they have to keep on adding, keep on figuring out till this with this number, and finding out that number takes time. That's why it is
Yeah.
slow.
Yeah. Understood.